Welcome friends, welcome to JCE Connect. Today we are going to solve few of the problems related to the tachometric surveying. This is part third. Here we are going to solve the problems related to the coefficient, the multiplying constant and additive constant. That is, you are supposed to determine K and C. Then we are going to see the problems related to the fixed hair method cases. Two cases are there. One is horizontal line of sight and second one is inclined line of sight. So let's see the problems, how to get that. The first problem, what it says is that you're supposed to determine the tachometric constant, where the tachometer has a diaphragm with a 3 crosshairs spaced at a distance of 1.15 mm. The focal length of the object glass is 230 mm and the distance from the object glass to the trunnion axis is 120 mm. Calculate the tachometric constant, what that first problem says. Now here you have to understand the focal length is 230 mm is given, and then along with that they have given the stadia interval, right? Stadia interval, I'll show you how it will be. Now if you take a stadia interval, see this is the diaphragm, where you will be having 3 crosshairs like this. The distance between each crosshair sets, right? So that we called as what? uh, Stadia interval, right? So here stadia interval is 1.15 meter, that what mm they have given, 1.15 mm they have given. So you will be having two sets, so it is going to be 1.15 plus 1.15. so this is total I, right? This is total I means the upper stadia interval and lower stadia interval, so that is going to be right, I. So here we are going to get that I, and then we are going to solve it. We know that formula for K, that equals to F by I, and C is equal to F plus that is F plus D, right? K is equal to F by I, here I have shown, and C is equal to F plus D, it is given here. So that, see, in the problem, given problem, F focal length is 230 mm and D is given 120 mm. I is the 2 times of 1.15, that is 2.3 mm. Then you can use the formula K is equal to F by I, that is going to be 230 divided by 2.3, it is going to be 100, and C is equal to F plus D, that is going to 230 plus 120, that is going to be 350 mm. Now it is not necessary that every time you should get C is equal to 0. You will begin, you are going to get some other values too. So this is what that first problem says, that we have got the K, right, multiplying constant, and C additive constant. Now if you read the second problem, what it says is that in the second problem, see what are things they have given. They have given, now first I'll read the problem. See, the stadia reading with a horizontal sight on a vertical staff held 50-meter away, means you'll be having a station, then you'll be having a staff, the distance D here, this is 50-meter away, right? This is 50-meter, right? This is 50-meter, and then they have cited that, right? Say this is the line of sight, and they have cited like this. The top reading is 1 point, means which one will be the larger, that is going to be here, that is 1.880, and here you will be having 1.280, right? So that staff intercept is, no, staff intercept they have given, means where the 1.280 and 1.880 are the readings, right? The focal length of the object glass from the tachometer is 240 mm, F is 240 mm, and the distance between the object glass and the trunnion axis is 145 mm, that is small d. Calculate the stadia interval. Stadia interval means here you are going to determine I value. Now see, what is the basic formula of D? D is equal to Ks plus C. Here we don't know K value, here we don't know C value. The given data, what the data is given, the given data is F, small f is given, small d is given, then S is also given. Only thing is that you have to determine I value, right? You are supposed to determine I value. Now that I value I am going to get. Now how I am going to get? See, I know what is this K. What is the K? K is F by I, right? Now this K I can write it as, see here, F by I, and I can write this C as F plus D. So F is known, D is known, here also F is known, but small I have to determine. So I can use this, capital D is known, so I can use this formula, I can get the I value. So that I am going to do here. So I am, see, I am going to write the first thing now the whatever data, the data they have given, that is focal length is 240 mm, that is going to be 2.4 meter. D is equal to 0.145, that is 0.145 meters, that is 145 mm. Horizontal distance D is equal to 50 meter, and then you will be having the staff intercept S is equal to 1.880 minus 1.280, it is going to be 0.60 meters. Then F plus D is 0.24 plus 0.145, it is going to be 0.385 meters. I'm going to use that D is equal to F by I into S plus F plus D, that formula, and I'm going to get the I value because capital D is known. Now here you can see that I'm going to use that D is equal to F by I plus S, I into S, and F plus D here. So F is 0.24, it is not 2.4 meter, it is going to be 0.24 meter. Previously I said 2.4, it is not going to be 2.4, it is going to be 0.24 meter divided by I plus S is 0.60, and no, F plus D, F plus D is 0.8385, 0.385, that is going to be there. So it is 0.144 by I, that is going to be 50 minus 0.385, then it is going to be 0.144 divided by I, that is going to be 49.615. I is equal to 0.114 divided by 49.615, it is going to be 2.9 into 10 raised to minus 3, it is going to be 2.90 mm. So I is equal to 2.90 mm. This is what this problem is there. Okay, my friends, so we are going to the problem number this is the problem number third. The two distances 50 and 80 mm were exactly measured, and the staff intercept on this staff were 0.496 and 0.796 meter respectively. Calculate the tachometric constants. Means here what they have given is that, see, two equations they have given. Means now you can do this, right? You can keep a staff there, so you can keep an instrument, take an instrument on a level ground and keep two staff, here one and here one. So this distance is no 50 meter, and this distance it is going to be 80 meter. For these things, means whatever things will be there, they have given this, right? So here also they have given staff intercept, and here also they have given the staff intercept. So here it is D1 and here it is D2, capital D1 and capital D2. That you can do, and you can get the respective answer. So as I know that D is equal to Ks plus C, I am going to put that here. See here, I'll be having the first equation, that is D is equal to Ks plus C, and that we are having D is equal to 50 meter. K I don't know, so I am going to keep as it is. S is given 0.496, and C I don't know, so this is going to be equation 1. Equation 2, with respect to the 80 meter, it is 80 is equal to K into 0.796 plus C, that is going to be equation 2. So by comparing equation, substituting equation 1 from 2, so what we are going to have is that 80 minus 50, that is going to be 0.796 minus 0.496 into the K. You will be having 30 is equal to 0.3 K. Here you will be having K value, that is 30 divided by 0.3, it is going to be K as 100. So this is what the required thing. So we got K as 100. Now substituting K in equation 1, so what we are going to get there, see, you can substitute that in any one of equation, but I am substituting here K in first equation. So it is going to be 50, that equals to 100 into 0.496 plus C. So we can easily determine C here. C is equal to 50 minus 49.6, C is going to be 0.4 meters. And this is what for this problem you have got both the values as a multiplying constant K as 100 and additive constant C as 0.4 meters. Now we're going to see one more problem here. Now I'll be reading the fourth problem, that is, the following set of readings are taken from tachometer. Calculate the tachometric constants. Distance is given, D is equal to 30, 60, 90 and 120, and staff intercept 0.295, means directly S value is given, 0.595 and 0.995 and 1.9 1.195. So here see, you can solve this as a no homework problem. I have written the K and C values here. I have given that, you just go with that. See, it is very simple. You can keep instrument at a station A, and you can have a several points, right? Several points with respect to the distances, different distances. So first is 30 meter distance, second is 60-meter distance, then you will be having a 90-meter distance, then you will be having a 120 meters distance. So based on this, see, D is equal to, you can take D as 30, K you don't know. Yes, you can take intercept as 0.295 plus C, that also you don't know. You can compare the all equations, right, with each other, and you can get K and C value. Now this is what from the multiplying and additive constant. Now if you go to the fixed hair method, we are having two sets of derivations there. One is when line of sight is collimation, line of sight is horizontal, and one when the line of sight is inclined. So we are going to see those, how to solve that problem. So my friends, first I'll read this problem. This is problem number 5. The elevation of point P is to be determined by the observations from the adjacent station of tachometric survey. The staff was held vertical. So staff was held vertical. So I'll be try to draw the figure. The staff was held vertical, and you know and the instrument is fitted with an analytical lens. Here instrument is fitted with an analytical lens means K is going to be 100 and C is going to be 0. The constant of instrument, as I said, that being a 100, K is being to be 100 and C is going to be 0. Compute the elevation of point P from the following data. The data they have given in this problem. See here, what you are having, station at A, staff, see, height of, what is that, height of axis they have given, right, means this they have given. So this is going to be 1.42. Staff station at P, right, P, this is, if I call it as A, then vertical angle, see, this is vertical angles they have given, right. So how it is going to be, vertical angle, one is 2 degree 24 minute and minus 3 degree 36 minutes, right, and staff interval is also given, elevation of station is also given, right. Okay, so we'll see that how to get this. Now here, which case is this, that we have to first understand, right, whether this is the line of collimation is horizontal, or line of collimation is um, vertical. If you take any sense, it is going to be give you the same answer, right. So first we are going to go with the line of collimation as inclined, right. So first with that I am going to go, see, calculate the distance of A and B from P, that what it says. So first, see, you can have observation from A to P. So what you are going to have here, observations, see, what are things you are going to have here. See, here you are going to have S value, that is 2.8 is 0 minus 1.23. So you are going to get the 1.65 meters. So D is equal to Ks cos square theta plus C cos theta, where K is 100, C is 0. So I put those values here. Theta value is given, that is 2 degree 24 minutes positive. So we're going to have D is 164.7 meters. So this is the distance between A and P. Then you will be having V. V, say K sine 2 theta by 2 plus C sine theta. So K is 100, C is 0. So we are going to have V as 6.90. So what will be the RL of P? Now if we, RL of P is equal to this, right, you are going to have, see that they have given the RL here, right, RL of station they have given 77.750. This, if you take 77.750, now if you get that, again I have to draw that figure. If you take this, and this is the line of collimation, right, if you take this stuff, now here, see, this RL of instrument station means this points RL they have given, right, here these points RL they have given. Now see, with this ground point to this, you are supposed to add H. Now this H is given, H means, see, this is 1.425. Then you are going to come here, right, and here you will be having the different readings. Then what you are supposed to do is that, see, where V is this, right, means inclination to the line of collimation. Your inclination to the line of collimation is your V, means I'll try to draw that so that you can easily understand that. It is very important thing. see here, if you take this, right, you'll be having a staff here. So actually this is going to be this, and you will be sighting here. Then you will be having like this. So you will be having V, then you will be having what? Now here I can show you easily. Now see this, RL of this station is given, means this point is given, that is instrument station, that is going to 77.750 plus H1, that is 1.42. Then you are going to come here, right? You are going to come here. Then plus V, you are supposed to go to here, right? Then minus H, then you are going to come to the ground. You getting this? See here, when when you are going to come here up to here, then you are supposed to go to this, then from this to this is your H, right? So it is going to be 77.750 plus 1.42, then you are going to come here, plus V you are supposed to add, that is V we have got 6.930, then minus H you are supposed to go to the ground, right? Means you are going to come down here, right? So it is going to be minus 2.055. So altogether it is how much? It is going to be 84.081 meters. Now this is what you have to go there. Now this is what I have written here. Now you can see that, right? 77.750 plus 1.42 plus 6.903 minus 2.055, it is going to be 84.18. Now this central reading 2.005 is going to be your H. Similarly, from the observation from B, see here what is going to be here. S is equal to the 2.03, D is equal to ks cos square theta plus c cos theta. K and c values we know that K is 100, C is 0. Then we are going to have D as 202.3 meter, V as we have got 12.72. Now it is going to be RL of P is equal to 97.135 plus H, that is 2.40 minus V and minus H, what they have given. The minus V and minus H, that you have to understand. Now if you see this figure, what I am going to have, now this is RL of ground plus H. If you are going to come here, then this is the RL of instrument axis. Now what is your V? V is, see this dotted line, this dotted line means line of inclined instrument axis to the line of collimation. This is your V, right? So here see, you are going to come here, minus V you are going to come here, then this is your H. H is here, so that you have to deduct there. So that what I have written here, that is 97.135 plus 1.40, so this is 93.175 plus 1.430. Now here if you see this, 97.135 plus 1.40 minus C, if you come here, minus V, it is going to be here, then minus H, right? Minus V minus H, you are going to get 84.14 meter, and the average elevation is, you can get the average, it is 84.16 meter. This is what from this problem. We'll go for the next problem, we'll see how it will be. Now if you read this problem, what is going to be there? Determine the gradient of the point A to a point B from the following observations made with a tachometric fitted with the analytical lens. Once if a tachometric is fitted with analytical lens, it means that K is 100, C is 0. Then held vertically, right? Staff is held vertically. Staff is held inclined is a separate thing. Here staff is held vertically, but the line of inclination is there, right? So we see that because we are having two vertical angles, 10 degree 32 minutes. If here vertical angle is 0, means you will be having a exact line of sight like this, right? Exact line of collimation. If this is there, here theta should be 0, but here we are having theta, two angles are there, it means that line of sight has some inclination with it. Now here instrument at P, staff at A and B, the bearing they have given, along with that they have given the vertical angles and the staff reading they have given. So here observation from P to A, see here, yes, we are going to get, that is 1.11 meter, and then, right, we are having D is equal to ks cos square theta plus c cos theta. K is 100, C is 0, we are going to get D as 107.3 meter, and you will be having V value as 19.95. Now here K is 100, S is 1.15, sine theta, theta here you are going to get the that is going to be see the theta is very important here. You are supposed to get the theta from V, it is right, from V. So let me check. Now here you can see that Ks uh, into half sine 2 theta, so it is 2 theta value, right? 21 degree 4 minute is 2 theta value, so it is going to be 19.95 meter. Now difference in elevation between A and B is, see, this is 19.95 minus 1.95, right? This is 1.95 is here, right? Now here you can see that 1.95, that is going to give you the difference in elevation. And now the same thing you can do from station P to B, where S is 1.64, D is, D you are going to get here, see here, D you are going to get it as 162.7 meter, V is 14.51, and the difference is 14.52, sorry, 14.52 minus 1.885, it is going to be 12.696. Now the gradient from A to B is, so you can have the right, bearing is given, you can have the square root of the values what we have got, and you can get the bearings, you can get the gradient there. Now you can have the gradient that you can take the distance AP is known, that is going to be, here it is 107.3, distance BP is, here it is, so it is going to be right, try to zoom in, okay, it is not getting zoom, right, so here it is 162.7. so now what we are going to have is that, see, if you see this, we are going to have AP square plus BP square plus 2 ABBP, right? ABBP, so that is going to get the that is going to get the square root of that is going to get the difference in elevation. So we are having 18.035 minus 12.635, it is going to be 5.399 meter. Gradient from A to B is this 5.99 divided by 194.9, that is going to be 1 in 36. So this is very important, 1 in 36. If you are having a negative answer, then you are going to write it as falling gradient. Now one more problem we are going to solve regarding the this one. What we are having is here, this is the problem number I think 7 problem number. We are going to see that tachometer is set up at an intermediate point on traverse, right, that is PQ, and the following observations were made. Staff is kept at P and Q, and these observations are made here. 8 degree 36 minute is the vertical angle from P, and 6 degree 6 minutes is the vertical angle from Q. You are having the staff intercept 2.350 and 2.055, as well as the XL reading, right, 2.105 and 1.895. Now what are these right, XL that XL reading means it is the axial hair reading, right, central hair reading they have given there. It means that H value they have given there. So what you have to do is that, see, you are supposed to find out uh, the elevation observation from first instrument station P we are going to see, then observation from instrument Q we are going to see. For the remaining things are, see, they have given the constant K as 100, and they asked us to find out PQ and RL of Q, that of RL of P being 321.5 meters. So PQ difference is also they have given here. I try to write that figure here. PQ difference is also given, and the observation from the instrument to P is equal to, right here I can show here, P is equal to Ks cos square theta plus C cos theta, that is going to be means height at P, right. It is going to be here, see, you are having, see, if you put all those values, you are going to get the 229.75 meter, whereas right? This is the d value, right? This is the d value p, no, not the height. This is the distance of p from the instrument station, right? 229.75 meter. And v, see, this is the height at p, right? V is equal to ks into sine 2 theta by 2 plus c sine theta. That is going to be here it is 37.745 meters, the value what we have got. So this is 2 theta, right? So here we have got 34.74 meter. Now what we are providing k is this, then you will be having ks value 2.350, that first value for first column, first row value you are going to take. Then you are having half of sine 2 theta, that is 17 degree to 6 point, right, you are having 8 degree 36 minutes into 2, so you are going to have 17 degree 12 minutes. So that we are going to take here. The final answer is 34.74 meter. The difference between the elevation is, see, here you are going to have, this is the 34.74 meter minus the central crosshair reading, that is 2.150, you are going to have 32.640. Now along with that you have to see the observation from instrument station q, right? That we are going to see now. Observation from instrumentation, what are things we are going to observe there? S is 0 point, S is 2.055 and theta is 6 degree 6 minutes. So you are going to get the d. First, the d from the instrument station is, see, here I have got 100 into 2.055 cos square theta. Theta is 6 degree 6 minutes. So you are going to have the value of 203.18. 203.18. Similarly, you have got the height here, height with respect to the q, that is 21.713 meter. So the difference in elevation from at q is 28 21.713 minus 1.895, you are going to have 19.181 19.818. So this is the difference at q, the height at q. So the thing is that since the tachometric setup at the instrument pq, the distance p and q is, see that you have got two, no, the instrument is set like this, right? The center here you will be having, say, this is p and this is q. So p, and if you take this o, po is known and qo is also known. So the total distance is 229.75 plus 203.18, it is going to be 432.93. so that what I have written here, 432.93, right? It is here. Then you will be having the RL of P, right? The difference in elevation between P and Q also you can determine here. Difference in elevation between P and Q, if you see that, now we are having few of the here the difference is 32.640 and is 19.818. So you are going to have 12.822. Then RL at Q is equal to RL of P minus 12.822. It is going to have 308.678 meters. This is a very important problem, you just keep in mind and just check it out how to solve such kind of problems. Now we'll see one more problem that is going to be there, and let's just check it out how to solve this. We're going to discuss it in brief so that you can take it as a homework. Here, determine the multiplying constant of tachometer. The following observations were taken on a staff held vertically at a distance measured from the instruments. Three observations they have did here, 1 2 3, and horizontal distances from all three they have given, right? And then have given the angles, and they have given the staff intercept also. So here, see, what you are going to do is that here you are going to do it as d1 is equal to k1 s1 cos square theta 1 plus c cos theta. Then similarly d2 k2 s2 cos square theta 2 plus c cos theta 2. Like that, for third value also you are supposed to do the same thing, that is d3 k3 s3 cos square theta 3 plus c cos theta 3, that you are going to do there. If you do that, then you are going to get the different values k1 k2 k3 and s1 s2 s3. All three values you are going to get. Then average of k and average of s, average of c, you are supposed to get. Those will be your k and c value. Now, whatever things we have described or discussed here, if you are having any problem or any doubt, please let me know. And this is what from my side. I am Professor Balasaheb Jamadar. Thank you.